The focus of this lesson is on solving absolute value inequalities. We'd start off by isolating the absolute value expression, but that step is already done. So we're going to go ahead and move on to step 2, which basically is saying that we can split our absolute value inequality into two inequalities. The first is exactly what we see, but without the absolute value symbols. So x plus 3 over x minus 2 is greater than or equal to 3. So that's one of the inequalities. And the second one is the same expression that was in absolute value symbols, but flip your inequality symbol and change your sign of the other side of the inequality. So either of these two inequalities replace our original absolute value inequality. And since that was the absolute value is greater than or equal to 3, that's distances beyond 3 units, this is an OR scenario. So either or have to be true. And that's important. So then we would rewrite each of these by moving the constant over so that one side of the inequality is 0. So we have x plus 3 over x minus 2 minus 3 is greater than or equal to 0. Or we have x plus 3 over x minus 2 plus 3 is less than or equal to 0. Give this first expression or inequality a common denominator of x minus 2. So this is x plus 3 over x minus 2 minus 3. You can think of 3 over 1 if that helps you, but then give a common denominator of x minus 2, which you do to the denominator, do to the numerator, is greater than or equal to 0. So this is x plus 3, distribute that minus sign, so minus 3x plus 6 all over x minus 2 is greater than or equal to 0, but that is negative 2x plus 9 over x minus 2 is greater than or equal to 0. So then we need to figure out where is this expression 0 and where is it undefined. Well, negative 2x plus 9, set that equal to 0. Take x minus 2, set that equal to 0. So the negative 2x plus 9 set equal to 0 will give us our zeros, whereas the x minus 2 set equal to 0 will give us our undefines. But then we need to solve for x in both cases. So subtract 9. So negative 2x equals negative 9. Divide by negative 2, you get x is 9 halves positive. Add 2 to both sides, we'll get x is 2. So x is 9 halves is a 0, and x is 2 is an undefined. So if we draw the number line, and I'll just do it to the left here, if we draw the number line that includes this, 2 is to the left of 9 halves, because 9 halves is 4.5. We know that we're 0 at 9 halves, and we're to include solutions that are 0 because it says equal to 0 in our inequality. So I know there's like a solid circle or a bracket at 9 halves. As far as x is 2, that's where we're undefined, so I know that's going to be open circle no matter what. But then what we would do, we would need to test which pieces, where would we be greater than 0. So we'd have to do a test point in each of these 3 intervals. So I'm just going to kind of auditory do it, but let's say we pick the value 1, which is in this leftmost interval. That would give us a positive over a negative, which is negative overall. So that's not greater than 0. So that won't be part of our solution. If I pick something between 2 and 4.5, let's say 3, that'll give us a positive over a positive, which is positive overall. So that would be greater than 0. And then if I pick something to the right of 4.5 or 9 halves, like 5, that would give me a negative over a positive, which is negative. So that would not be included in the solution. Now this is just one of the inequality solved through. That's its number line, so we'll keep that in mind. That's not our actual solution yet. We also have to consider the fact that x plus 3 over x minus 2 plus 3 is less than or equal to 0. So we'll rewrite that with a common denominator of x minus 2. So x minus 2 in the denominator, do the same thing in the numerator. And we know that whole value is going to be less than or equal to 0. So write that as one rational expression. So that's x plus 3 plus 3x minus 6 over x minus 2 is less than or equal to 0. So that's 4x minus 3 over x minus 2 is less than or equal to 0. We're going to be 0 when 4x minus 3 equals 0, and we're going to be undefined when x minus 2 equals 0. So I'm going to go ahead and add 3 to both sides. 4x is 3, divide by 4 on both sides. X is 3/4 is a 0. Add 2 to both sides here. X will be 2 is an undefined. So the number line that corresponds to this piece, I'll write up top here. 3/4 is to the left of 2 on a number line because it's smaller. And then if I do a test point, now I'm looking for solutions where we're less than or equal to 0. Now I know we're equal to 0 at 3/4. I know we're undefined at 2. Now I'm just looking for where are we less than 0. So pick something to the left of 3/4 for this interval. So let's say you pick 0. Plug that in, and you would see if you plug in 0 here into 4x minus 3 over x minus 2, you'd get a negative over a negative, which is a positive, but you're looking for where you're less than 0, so that's not where we're less than 0. Pick a test point within 3/4 and 2, so maybe like 1. So plug 1 in for x. That would give us 4 minus 3, which is positive, over 1 minus 2, which is negative. A positive divided by negative is negative. So that is less than 0. So that would be part of this expression's solution. If I pick something to the right of 2 like 3, that would give us 4 times 3 minus 3 is positive over 3 minus 2 is positive. A positive divided by a positive is positive, but that's not what we're looking for. We're looking for where we're less than 0. So then now if I put both of these pieces together on a number line, remember this is an or scenario, so either or, either solution works. So and so I'm going to put them all on one number line. So put the values 3/4, 2, and then from this one it had 2, which I already have, and 9/2. Draw the solution pieces. So for this first piece we had a solution from not including 2, so a parenthesis at 2, to 9/2 inclusive. So put a bracket at 9/2. And for the second piece we had it from 3/4 inclusive to 2 non-inclusive. But since it's an or scenario, either or works. Put those together on a number line. We can see that the solution would go from 3/4 to 2 union 2 to 9/2 inclusive on the 9/2, and that would be our solution overall. So it has two pieces.